CPU Galaxy.
Hello and welcome to the CPU Galaxy channel. And today I want to review a motherboard which I was searching for since years to get it. A board which gives us a lot of interesting possibilities for testing, benchmarking and experiments I wanted to do for a long time already. Actually, I got this beautiful board from my friend Mike, who is also a fellow collector from my country. And for those who don't know yet from which country I am, yes, I'm from Austria, and no, we don't have just mountains, cows and farmers here. We have also technology in Austria and at least 2 CPU collectors. The board we are talking about is the OPTI 495SX3/486 write-back cache. It comes up with the OPTI 495SX chipset, 256 kilobytes of L2 cache. Over here 8 sockets for 30-pin RAM, actually 8 megabytes are installed. Over here we have the standard 80 power connector, a battery which was fortunately not leaking and I replaced it already. We got 8 16-bit ISA slots with, and 2 with additional Vesa Local Bus slots. The local bus was a huge performance improvement for video cards back in the 90s. It is not limited with a bandwidth of 16-bit and 8 MHz as on the ISA bus. The local bus is directly connected through the 32-bit bus to the CPU and clocked with the same speed as the CPU. And here we come to the interesting part of this board. We have here a socket for a 386 CPU, and over here we can put a 486 CPU. So this board can cover 2 generations of x86 CPUs, which makes it very interesting for some benchmarkings and comparisons. The main reason why I wanted to test this board was that we have the possibility to use a Vesa Local Bus video card on a 386 CPU, which is not very common. From 486 systems we know that the choice of a slow ISA video card is a bottleneck which is very much affecting games like Doom. So in this video today I want to see how much performance increasement we can get here with a decent video card. But first let's have again a closer look on our sockets here. Here we have the 132-pin socket for our 386 CPUs. Due to the fact that the mainboard is a very late mainboard for 386 CPUs, it's I think from the mid of 1993, the BIOS is supporting a lot of different 386 CPUs. And let me show you what I tested so far. So we can put here Intel CPUs from 20 to 33 megahertz, older versions or newer version, so they are working quite fine in this mainboard. We can also put all kind of AMD 386 CPUs here from 25 to 40 megahertz, as well as some 486 upgrades for the 386 sockets, like from Texas Instruments, the DX-40 DLC with 40 megahertz. Actually it's a Cirrus core inside. We can put here also the Texas Instruments 486 SXL 250 with a frontside bus of 25 megahertz and internal clock doubling to 50 megahertz. Also this kind of Cirrus CPUs, same as the Texas Instruments, which gives us 25 megahertz on a frontside bus and clock doubled inside to 50 megahertz. We can also put here the Cirrus CPU, the CX46 DLC with 33 or also up to 40 megahertz. And at the end also something very rare, the Intel Rapid Cat, which is also some kind of 486 implementation for a 386 socket, but I think I will do on this particular CPU a separate video once. So we can see here a lot of processors we can put here inside these sockets, which is at the end very interesting. So for a long time I was searching a mainboard which can cover all of these chips for this socket. Also interesting to see, inside the socket we can see here some solder pads and we got here the possibility to solder a floating point unit as it is existing from Cirrus. Yeah, not that I have the focus to do that, but it gives us at least the possibility. Yeah, and over here the socket for our 486 CPU. Basically we can jumper the board between 20 and 50 megahertz, so this gives us also here a lot of possibilities for CPUs we can put here. Yeah, for instance, we can put here all kind of Intel 486 CPUs from 20 megahertz up to the DX-33 or DX-266. So everything is possible here. Also AMD CPUs, the DX-40 with 40 megahertz or DX-266 as well. So everything no problem, and it runs without any troubles in this board. Also Intel overdrives we can put here, for instance a 40 megahertz overdrive or 66 megahertz 486 overdrive up to 100 megahertz. Basically the socket provides just 5 volts, so unfortunately 3.3 volt CPUs we cannot put directly into the socket, but a overdrive as this here has voltage regulators on board, and we can put also the 100 megahertz DX4 in this case into these sockets, or also maybe a 133 megahertz CPU as this Kingston Turbo chip, which has also voltage regulators on board and comes up with a AMD X5 133 MHz CPU. So also here we can see a huge amount of possibilities we have here for testing, which makes this board really interesting. Yeah, and you may ask now, if we install a 386 CPU, which doesn't have a floating point unit inside, where the hell we can put a floating point unit? So, and as we can see here on the socket for the 486, we have 2 rows here more than a usual 486 has. So the outer 3 lines of pins are used for the 486 CPU, and the inner 2 lines are used for a floating point unit to use beside the 386 processor. So I can tell you now something very tricky, and I burned already my first floating point unit I put here. As we can see here on the silk screen on the board, in this corner is a little bit flattened, and this indicates our pin 1 for the 486, of course. And I tried this, and this was also working. So then I wanted to put here the floating point unit, and for me it was clear. Here we have the pin indicator 1, and I was putting also the floating point unit like that into the socket. When I switched on, I had a full short, high current and so on, and the floating point unit was of course damaged. Also here the pins got a little bit warm and the plastic was a bit melting. So I was a little bit confused, and then I was checking a little bit more the specification and measuring around. And this white, whatever is this here, it's not even a spot, should indicate the pin 1 for the floating point unit. So it's exactly turned around. Yeah, very confusing. If you have this board, please take care that pin number 1 for the FPU is here, and pin number 1, the indicator, is here for the 486. So I have no clue why somebody is designing like that. Yeah, maybe you have an idea, let me know, because anyhow the pins are not shared between the 486 and the 387 here. Last but not least, due to the fact that we can put here also a floating point unit, we got also a lot of possibilities as the Intel 387, or from ULSI some floating point units. From Cirrus we can put here a FPU, also this soldered version. From IIT we can put here a different kind of floating point unit, or from Chips Technologies. So also in terms of floating point units we can put here everything at the end. So I think I will use this board in future a little bit more often for some testing, benchmarkings and comparisons. So you might see this board appearing on my channel for several times, of course. Yeah, and that what was not even the last thing this board can offer in terms of CPU compatibility. If you would like to do so, you can also solder here the QFP packages for the 386, or it's also existing for the 486, the SX version. So if you have mood and a lot of fun with soldering, you could solder here also one of those CPUs. Yeah, the only thing, unfortunately, you cannot leave the 386 and the 486 inside the board and just jumper the version you want to use. You need to remove always the other one. But nevertheless, a very interesting and powerful board. And yeah, so let's go ahead now with some testing and let's see the outcome. So it's time now to build up our setup. For the CPU, I will go for the AMD 386 DX with 40 MHz. It's actually the fastest 386 CPU we can get. Why these things are always falling? With the hard disk drive, I will go for the Western Digital 2850 with 850 megabytes. So this is also a quite fast hard disk drive from the mid of the 90s. And we are going to check the transfer rate between a 16-bit controller compared to the local bus controller. Yeah, for the 16-bit setup, we need of course then a IO controller, a just common one from Winbond, which gives us the possibility to connect our hard disk drive. For the video card, we will go for the Cirrus Logic GD5428. It's one of the fastest 16-bit video cards. It's actually also a very late one from 1995. So this is quite a good challenge at the end to compare with the Vesa Local Bus card. So for the 32-bit setup, we have of course then a Vesa Local Bus IO controller. Here we have the possibility to connect two hard disk drive. I am also very curious if we can increase the performance for the hard disk transfer rate with the VLB controller. For the video card on the Vesa Local Bus, we go for the Tseng ET4000 WP32. So this is also one of the fastest Vesa Local Bus video cards. Yeah, let's see if we can get a decent performance improve with the 386 CPU within gaming. So, time to switch on. I love the sound of the hard disk. Yeah, the BIOS is also just straightforward with all this standard stuff we know already. Advanced TMO setup, not many things to set here. Internal, external cache memory can enable or disable. Of course, internal right now it is not possible because our 386 don't have an internal cache. So what else does this BIOS have? Here we have hard disk utility and auto detect hard disk. So this is very comfortable. So we can automatically detect the parameters of our hard drive. Let's check if it's still here. Yes, everything fine. 814 megabytes. So everything detected nicely. So then let's boot up this thing. Yeah, and it's booting straight away without any issues. Yeah, then let's start first with Norton sysinfo. We can see here our 386DX clocked at 40 MHz. Also a quick CPU benchmarks gives us here almost a rating of 40. And then let's go on with SpeedSys to check the memory throughput of the video cards and the performance of the hard disk drive. Yeah, for our 16-bit configuration, we get here around 4 megabyte throughput for the video card, which is not that bad for a 16-bit card. The hard disk drive shows up with 1.8 megabytes of transfer rate and an average seek time of 8.77 milliseconds and a maximum seek time of 12.34 milliseconds. So, and at our local bus configuration, it's getting interesting now. The video performance comes up with a throughput rate of about 20 megabytes per second. Yeah, this is 5 times faster than on the previous card. So we can see here a huge improvement in terms of moving data through. But for the hard disk drive, to my surprise, we don't see any improvements. Instead, it is getting slower. We got only a transfer rate of 1.4 megabytes, so 400 kilobytes per second slower. And also the timings are a little bit slower. Interesting, and I have no idea why this is happening. I cross-checked also with other controllers and I get always the same values. So leave me a comment below if you have any idea why this is happening. Yeah, at Landmark we get about 5100 characters per second for the 16-bit video card and about 15,000 with the ET4000 Vesa Local Bus card. So again, here a big improvement of 3 times. Also at Dr. Hardware we can measure a big improvement for 8, 16 and 32-bit operations on the video cards. Although these are just some synthetic benchmarks, I'm already very curious how big the gap is going to be at gaming and 3D benchmarks. Especially Doom, I'm looking forward how much frames we can get more with the Vesa Local Bus card. Then let's summarize now in between before we go for gaming. The hard disk drive is out of the game and the ISA controller made it clearly in this comparison. Transfer rate and timings are significantly better there. At the video cards we have also a clear result, which I was expecting. In terms of memory throughput and characters per second, the local bus card can shine here because of its 32 bits and the high clock rate on the bus, so a clear massive improvement. Yeah, then let's go ahead with gaming. For 3D benchmarking I was using of course 3D Bench, PC Player at 320 to 200 and Doom. Yeah, all of them were slideshows and no matter if I use the ISA card or the local bus card, especially Doom. Of course we know that Doom is not nicely playable on a 386, but the results were anyhow disappointing to me. And here the chart. At PC Player we gained nothing, 0.1 frames. Also not even 1 frame more at Doom with the local bus card. And 3D Bench was so kind to give us a bit more than 1 frames per second. Of course we can measure a slight improvement, but nothing serious. So what does this tell us now? The local bus card is of course much faster to push data through, but if it comes to process the data, the bottleneck is then clearly the CPU. I think 8 frames at Doom is the limit with a 386 DX-40 at a screen size of 8 and high details, although I was hoping to get a little bit more. Yeah, does it make sense to have a local bus configuration on a 386? Definitely no. Those boards are nowadays very rare and hard to find, and also very expensive. So if you go for a 386 setup, just consider to use a good ISA video card. All games of this era are working quite fine, no matter if you play any pinball flippers, which I like very much by the way, or Monkey Island with its great sound. At Prince of Persia, running through the temple basement to save the princess, or Wolfenstein, all these games are not so CPU demanding and they fit perfectly for a 386 setup. At the end of the video let's play a little bit of extreme pinball. I pimped the 386 with a Gravis sound card to enjoy the game. Thank you very much for watching and see you soon.